The final stage of annealing is the grain growth. The first stage is recovery, second recrystallization, and it is followed by grain growth. So, grain growth, as the name suggests, is increase in the average grain size, and this obviously, since the total volume of the material is constant, will lead to decrease in the number of grains. So, you can see here a fixed volume of material with a fine grain microstructure when is undergoing annealing and after recrystallization. So, the grains will increase, and this step is called the grain growth. Grain size is increasing, but since the total volume of the material is constant, the number of grains, because same volume is now divided into a smaller number of grains to have larger grain size. So, it is obvious that the driving force for such a process is the reduction in the grain boundary surface energy. So, the driving force is a reduction in surface energy associated with grain boundaries. Let us try to do a simple calculation related to this. So, let us say that the initial grain size, so we are trying to calculate reduction in grain boundary surface energy due to grain growth. So, let the initial grain size be be d initial di, and let the final grain size after grain growth be df. Now, assuming spherical grains for simplicity of calculation, so assuming spherical grains, we have, so let us say volume grain boundary surface area, initial, final. So, the volume will be pi di cube by 6, it will be pi df cube by 6, and the surface area will be pi di square pi df square. But remember that we are talking of grain boundary surface area, and this will be area of one grain, but each grain boundary is being shared by two grains. So, grain boundary surface area per grain will be half of this. So, the factor half is coming factor half as grain boundary is shared by 2 grains. So, now we can calculate the surface area per unit volume, grain boundary surface area per unit volume. So, we have the grain boundary area is half pi di square and the volume is pi di cube by 6. So, this will give you 6 pi di cube by 2 pi 6 pi di square and 2 pi di cube. If you cancel pi, d square will cancel and you will have 3 here. So, you will get a nice simple formula of 3 by di. Similarly, in the final case you will have 3 by df. So, the change in grain boundary surface area per unit volume will be 3 by df minus 3 by di, and you can see that this is negative as df is more than di. So, there is a reduction in surface area. Associated with this reduction, there is a reduction in grain boundary energy per unit volume, and this is what is the driving force. For grain growth. C by df minus C by di times gamma, where gamma is grain boundary energy per unit area. So, this is what in the way we can approximately calculate it. Of course, recall that our assumption was of spherical grains, and spherical grains of course will touch each other only at a point. So, this assumption itself is not correct, but an order of magnitude estimate can be found using average grain diameters, using a calculation like this.